Hi there guys, and welcome to another tutorial here on Science Sidekicks. We're here again in Tinkercad and we've got our Arduino and we're going to be creating a circuit this time where we have multiple LEDs in parallel and we're going to be using a transistor. So this video is really about what a transistor is. So you can connect up a bunch of LEDs in parallel or series and have them controlled by one of these GPIO pins directly. However, these pins can only carry a certain amount of current. So although you're providing 5 volts, each one of these LEDs is drawing a certain amount of current, and the more of them you have, the more current you're going to pull, and you can actually exceed the maximum current rating for these pins. So these pins are not really meant to drive things directly. If you have a big appliance like a motor, then you're going to use these I/O pins to trigger a relay. In our case here, as we're not powering something very large, we are just going to use a transistor. So a transistor, as you can see here on our circuit, has 3 pins. And we've got one pin connected, which is called the collector pin, which is connected to the ground or the cathode coming out of our LED. We have the emitter pin, which we have connected to the ground of our circuit. And then we have the base pin, which is connected to our controller. So the middle pin, the base pin, is our control pin. That's connected to the I/O through this resistor. So you can see here we've got I/O pin number 2 on our Arduino, goes to the resistor and goes into the base pin there. And on the collector side, we've got the ground coming from our cathode, and on the emitter side, we're going back to the ground here. Now I have a separate power supply because we want to supply more power than the Arduino is capable of, for example. So rather than powering from the USB, which can provide a maximum of 500 milliamps, let's say we had something that was going to draw more than that, or we had multiple circuits like this, then we need an external power supply that can provide more power. So we have a power supply here that's capable of supplying up to 5 amps at 5 volts. Now we're not going to need the whole 5 amps here, but this is just an example of how you can use an external power supply to power our circuit. So the positive and negative from the external power supply are going to our positive and negative power rails on our breadboard. And then we have a common ground. So the Arduino is still going to be powered by the 5 volt supply, and we have a common ground which is coming down here to the ground there. And you'll see that also our transistor is coming to that same ground. So everything must run to the same ground. That's one of the important things that you need to remember here in this circuit. And now if we take a look at our code, it's very simple. We're setting pin mode 2 to output. So pin number 2 is going to be an output. And every second, we are going to switch between high and low on that pin. So digitalWrite 2 high, delay 1000 milliseconds, 1 second, digitalWrite 2 low, delay 1000 milliseconds, and this will just loop and repeat. So now if we run this, we're quite simply going to see all of our LEDs flashing on and off. And you can see every time they come on, our current here is shooting up and then going back down. So these, how many have we got? 1, 2, 3, 4, 5, 6 LEDs are pulling around 88 milliamps. So I believe that one of these pins should only have a maximum of 20 milliamps on it, on the Arduino. So obviously, if we were running this directly off of the pin, we could be exceeding here the amount of current that we should put on this I/O pin. So the I/O pins are not really meant to drive things directly. They are meant to signal. They can only sink a small amount of current. So they are just a signal pin. And then we're using the transistor as a logic gate here, basically. Every time the pin turns high or low, the transistor is opening and closing its circuit and allowing the power to flow through it, which is coming from the positive rail of our power supply and then coming back out to the common ground here. So effectively, just think of the transistor as a little switch inside of there. That little switch is being controlled by our I/O pin, so we're not putting a lot of current load on this, and the current is flowing not through our I/O pin on the Arduino, but flowing across the transistor as it opens and closes. So I hope that that helps to explain how you can use an external power source with a transistor to trigger and turn on and off some string of LEDs or whatever it is. So you'll see quite often in these demonstrations that we're using LEDs. That just for show, it could be any kind of appliance that you have connected up here that you want to turn on and off that potentially is going to draw more current than what those pins should have. And just as a general practice, you do see a lot of people connecting the LEDs directly to the I/O pins, but it's not advisable. So there's a short introduction to how you should use the I/O pins on your Arduino when you want to turn things on and off. Try not to drive them directly. Always good practice to put them through a transistor. Thanks for tuning in. Don't forget to like and subscribe, and I'll see you next time.